Okay, just a moment. Can anybody confirm that you're seeing my presentation?
Yep, we can see it and we can hear you.
Okay, it's here. Good, great. Hey there. So my name is Andrei Voinescu. I'm hailing from Fitbit. My background is in embedded and distributed systems, and I've been with Fitbit for 3 years, and I've worked with Nuttx for 2.5. I'm currently the tech lead for Fitbit's fork of Nuttx. I'd like to start the presentation by thanking our hosts for organizing this event in these trying times. It's great to have the opportunity to come here and talk about what we like working on best. This presentation was supposed to be just about what's specific for Fitbit, actually a poster presentation at the physical event. But now it's grown into something much larger. The organizer have asked me to also include a short introduction of Nuttx, and I hope it will pique your interest. So what is Nuttx? The quickest way to describe it would be to say that it's a tiny Linux with built-in real-time capabilities. It was developed by Gregory Nutt to fill the gap of a small open source POSIX-based RTOS back in 2007. While it was low-key for a lot of years, it has gained traction recently. The core principles of Nuttx, in my opinion, are strict compliance with POSIX, a modular architecture that also scales well, the use of open licenses that exclude copyleft, and a consistent coding style. These principles create code that's highly portable with a potentially very low footprint and easy to navigate and read. A license allows it to be used in a lot of applications where GPL would be impossible to integrate. Nuttx is available everywhere. It has a lot of architectures and boards. I couldn't list them all even if I wanted to, from 8 and 16-bit microcontrollers to most of the ARM variants and to x86 on 64 bits. Let me make sure that I don't get any other notifications. So where is Nuttx used? There are a variety of products that you can see here, from digital audio recorders, Bluetooth headphones, robots, drones, various IoT devices, even physical printers. Of course, now we'll talk about fitness trackers as well. So now let's look at what an OS generally does and what Nuttx has to offer in that regard. In general, an OS is a piece of software that helps manage computing system resources in order to enable various user applications. It offers arbitration and abstractization of computing resources, be they processor time, memory, or I/O interface. A user application doesn't know and shouldn't know when it should use processor time, when it should leave other applications to run. And a processing abstraction, which I have on the left-hand side, it considers it as the only one running and lets the OS schedule time allocations for each application in the system, run interrupt service routines, and so on. An application doesn't know how it was loaded, whether it was dynamically loaded or not, as the OS takes care of that as well. Similarly, applications benefit from storage abstractions, where applications only write to files, not caring whether those are files on the network, in a flash file system, or actually in file system representations of OS structures. The I/O abstraction hides arbitration and fiddliness of I/O peripherals or networking stacks behind simple file and socket interfaces through device drivers and the socket API. The memory abstraction has wide variations in Nuttx based on hardware capabilities, from a flat build which only provides access to a basic heap and stack, to a full kernel build which allows processes to have their own address space, protection, and on-demand paging. So all of these abstractions allow applications to run based on a set of POSIX APIs and libc functions on top of those to run on various platforms and in varying conditions. As opposed to running on a normal PC with Linux, user applications have the added benefit of an RTOS, which is deterministic scheduling, which is of course affected by application priorities and interdependencies. So let's work on an example here. An application wishes to get data from a sensor as soon as possible. The sensor triggers an interrupt when data is available. The ideal chain of events would be an interrupt service routine that signals a driver worker thread, which transfers the data back into a buffer from which the application then reads. If the driver worker thread and the application have high priorities, then with respect to the rest of the system, then this is exactly as it would unfold on an RTOS. This delta t here would be a very small time frame, and deterministically so. On a non-real-time system, there would have been no guarantee of either the driver thread or the application executing so quickly. Notice that the application only called open, read, and close to achieve this behavior. So everything is transparent to it. So in terms of processing abstractions, the application code itself runs unaware of the scheduling, of task priorities, or when it has to be preempted, or whether other tasks have to run or interrupts have to run. Nuttx also offers p-threads, meaning tasks can spawn threads whose management is also taken over by the OS. And of course, other tasks can also exist in the system, and interacting with them is either through standard synchronization primitives or IPC, inter-process communication systems. The task itself doesn't have to block or unblock itself, set expiration timers, or deliver signals. The OS offers convenient standard interfaces for these systems. Nuttx comes pretty close to the Unix mantra of everything is a file descriptor, because everything can be. Sometimes it just isn't because of memory considerations. The pseudo-root file system serves as a simple in-memory root folder with mount points for all the file system that the particular instance of Nuttx needs. The range of file system covers most of those needs, with FAT, for instance, network file systems, in-memory file systems, Flash with where leveling, and pseudo file systems which give access to OS structures. In terms of I/O abstractions, the basics revolve again around offering device drivers that appear as block and character drivers. Character drivers are easily interfaced through open, read, write, ioctl close calls, while block device drivers require mounting and interacting through the virtual file system. On the networking side, the socket API is a POSIX standard interface to networking stacks. In terms of what is actually supported, the list is huge and wouldn't have fit even if I dedicated multiple slides. So I encourage you to check the wiki or the code for peripheral or device that you need in your application. I specifically called out here several peripheral drivers like I2C, SPI, PWM, CAN. There's a full TCP/IP stack. There's also a 6LoWPAN port. It offers a lot of USB host and device drivers with communication device class, human interface devices, and mass storage. For memory, the abstraction itself varies without the application itself being aware of it. The application is given a stack to run on and to store local variables, a heap with malloc and free interface, and access to the application global variables based on how the application was linked and loaded. The memory itself, though, may be in a different address space from the rest of the system or not, and that's based on the existence in the system of a memory management unit, MMU. The rest of the system may be protected from invalid or unauthorized accesses if there's an MPU. And these are transparent to the application itself. Besides these abstractions, Nuttx also offers system-wide power management. In the user space, it has a window manager. It has support for several interpreters, for instance, Lua or JavaScript, and it has its own version of libc. If you want to know more, you can check the Nuttx page, wiki, or even the code, as we probably already have. So now let's talk a bit about Fitbit and fitness trackers. Fitbit is a US company based in San Francisco, founded also in 2007, just like Nuttx. It focuses on wearables, activity trackers, and smartwatches. Maybe you can see here if I, with accompanying software. Fitbit devices measure steps the wearer has taken in a day, their heart rate, their sleep quality, and more. Our mission is to empower and inspire users to live a healthier, more active life. The Fitbit community is 28 million people strong and has grown every year. Fitbit has sold over 100 million devices, counted trillions of steps, tracked billions of minutes of exercise, hours and nights of sleep. Fitbit is especially well known for fitness trackers, and it has led the tracker category for 12 years. There are a couple of footnotes here, but we can move on. This is our current product lineup. It consists of, from left to right, the Fitbit H2, which is a fitness tracker for kids, Charge 4, our top-of-the-line fitness tracker, the Inspire and Inspire HR, which stands for heart rate, because one of them is without the heart rate sensors. These are affordable, lightweight trackers. And on the right side, we have our smartwatches, Versa Lite, Versa 2, and Ionic. Not included in this pictures are the wireless scales, but you can look for those on Google. So which of these trackers have Nuttx? These are the ones that we've launched up to now. Charge 3 was launched in October 2018. Inspire and Inspire HR in March 2019. H2 in June of the same year, and Charge 4 April of this year. I won't bore you with the details of all these devices, so I'm just gonna talk about more about our latest device. Since it has this super set of features found on other trackers. So it comes in multiple colors with multiple bands. It has real-time pace and distance. It has a lot of workout modes. These are marketing slides. These are the features. So the Charge 4 boosts continuous monitoring for heart rate, sleep, with sleep stage detection. When a phone is near you, when your phone is near you, you can receive call, text, and app notifications. It has up to 7 days of battery life. It does track all the activity and auto detects exercises, but the user can also start bespoke exercise types, which now also include winter sports, but the list is growing. It's more than 20 exercise types. Sync itself is wireless and can be configured to run automatically, so you don't have to worry about that. Fitbit specific nudges reminders to move, which gives an incentive for users to do at least 250 steps per hour. We think that's quite healthy. There's a few common use apps, like alarms with smart wake, timers, a weather app. New in Charge 4, which we didn't have before, is a built-in GPS. Previously, we had a connected GPS system where it would use the GPS of the smartphone, but now it has its own GPS. So that means you can go for a run without a phone, and it will record all the exercise stats as well as the location. Your track then can be color-coded based on workout intensity, and you can see that in the Fitbit app. Fitbit is known for pushing the 10,000 steps a day as a good fitness goal. And in line with World Health Organization recommendations, Fitbit also now tracks active zone minutes as a good daily goal to have, as it automatically tracks minutes spent in fat burn or cardio, peak heart rate zones, and monitors them daily. So what else? There's Spotify on-wrist music control, Fitbit Pay, which is a method of using your tracker or smartwatch to shop or use transit systems. This is subject to availability, so you should check online for your bank of choice or transit system. And that's about it for features. Let's talk a bit about the Fitbit fork of Nuttx. To integrate and extend Nuttx to be able to develop fitness trackers, we follow the guidelines outlined here. Keep POSIX interfaces everywhere, keep solid design principles around modularity and scalability, and last but not least, maintain the coding style. While the coding style is different than most other large-scale open source projects, it makes the code very easily readable, and it does grow on you. Also makes you fun at parties. As an anecdote, I was supposed to meet 2 old college friends for beer to catch up. Even though I wasn't late by a large amount, when I got there, they were arguing about coding styles. And they were quite happy that I was there to settle the matter. Andrei, quickly, do you put the opening phrase on the same line or on the following line? Clearly, this was one of the most divisive topics for programmers, and I of course say on the following line, indented by half a tab, overly satisfied with seeing their jaw drop. So there are many areas where we made modifications, but we also needed some new subsystems to serve our purposes. So we extended the IPC mechanism to include an end-to-end publisher-subscriber communication pattern, as well as a system-wide key value store. We also added init, which is a task that specializes in run level management and task starting, stopping, and monitoring. Event D is an event-based worker thread that fairly cheaply allows quick responses to internal events. For instance, you want to do something when a specific pop-up message appears, or do you want to do something repetitive that's something like time-based logging or other such things. We also added some layers to the driver system where we have sensor upper half drivers and common sensor upper half drivers. We of course have Fitbit specific modules, the sensor data collection and processing, which holds a collection of algorithms for steps, heart rate calculation, etc. There's an entire stack that allows secure communication directly with the Fitbit cloud. Part of it is available now as an open source project. Look for Golden Gate online. Then there's the entire over-the-air firmware update mechanism that we have, and we also added drivers for all the parts that we needed for these trackers. There's an UI stack as well, which is something that we use on all our devices. Here's a simplified block schematic of our system. So you can see here the tasks that we've added, init D and event D. Here's a module for sensors and algorithms, and it runs on top of the specific upper half drivers that it needs. For instance, if it needs altimeter data, accelerometer data, etc. These are all built on top of a common pattern, which is the common sensor upper half. And then there's the lower half drivers, which had to be specific to each tracker. These rely on the board support package with I2C support or SPI or QSPI or whatever connection was needed to those parts. And then it ties to the sensor hardware. The Fitbit UI interacts, it's actually layered as well. And there's an app framework layer, which uses direct connections to frame buffer, vibe motor driver, the button, and the touchscreen. These are all POSIX drivers, and the app framework layer is the one that actually opens those drivers and interacts with them, then feeds events to the upper UI stack. So this is for display, haptics, and the button. Our entire networking stack is based on socket APIs, which are built on top of the BLE stack that we have from our chip manufacturers. As file systems, we only use ROMFS and SmartFS because our storage is in Flash. And as I said, we also added some IPC. So the team has varied a lot during development, to the point where the original proponents of Nuttx are no longer with the company. Former R&D was mostly in US and Romania. Currently, the OS team, we call it the platform team, is in Bucharest. Other product teams are in San Diego. So those are the teams that develop the products on top of the OS, and other subsystem teams are across all Fitbit R&D offices. So thanks for a lot for your time, and I'll gladly take questions.
Okay, thank you very much, Andrei. Let's see if we have some questions here. We have one question from Marcus Miller. How exact? Sorry, I think it's asking to other question, but he asking about how it's related to operating system. I didn't.
Alan, I can watch through YouTube as well. So there's a question that says, I would like to ask you about the heart rate zones. Since they are very specific for every person, do you have predefined values, or you leave the user to enter the correct values for the zones? So these are based on age, as far as I know. So when you create your profile in the Fitbit app, it sets your heart rate zones, and then you can modify them to something else. So you can customize your own heart rate zones to fit your needs.
Okay, perfect. Let's see, we have some questions. Okay. If anyone else has some other questions, please write here in the YouTube live chat, and Andrei will reply. And also, we will put the link in the video description to our forum. So after this presentation, people here will be able to still asking some questions to Andrei. Okay.
I'd also like to mention that there's presentations from my colleagues, Julian, Vlad, and Cosmin, which are further down the line to give more details on some and enter in more in depth on some topics.
Yeah. Did you see the question from Brennan?
Yes, I did. So Event B is actually designed by our colleague Cosmin Petrișor. It's link time and runtime registration. So it's a sort of a mini scheduler for chunks of code that you need to run quickly. You set some triggers and then some callbacks to run after certain triggers hit, and that's it. And you can do that, as I said, at link time or at runtime. It's fairly versatile. The only problem is that it can be abused. So you have to take care of what kind of code people put in there, because if it can be very big in terms of stack usage, and it all runs on the Event B stack.
Okay. We have another question from Johannes. Is some of init D and Event D supposed to be mainlined?
We are having, yes,
Sorry.
we are having internal discussions on this topic.
Oh, great. Other question from Marcus Miller. Event D is basically a real-time scheduling domain.
I think you could say that.
Okay.
Unfortunately, we don't have a presentation on Event D.
Yeah, should be nice, because it's a very interesting topic. And as you know, I don't know if you follow the mainline mailing list and pull requests. We have some event Ds pull requests recently related to event, not exactly what you have, but in this same direction. Other question from Masayuki. What MCU are you using for Fitbit tracker? Sorry.
So here it's a bit weird, where I would encourage you to check the sites that do these assemblies of products, as I was told not to say exactly which MCU we are using, but it's fairly easy to find online.
Okay. I think I already did my my homework. I can I reply to Masayuki, or is better he search for himself? If it's forbidden, I will not say. But if you allow me,
No, it's okay. I can't say. That's it.
Okay, Masayuki, they are using STM32 at least for the previous generation. And I used it to help a guy from Fitbit few years ago. I think his name was Liam, Liam, Liam Mac something. I can recall his name. And he was working with STM32, and he was working in the Kemu, the emulator. Okay.
Yeah, so the STM32, I think, is a previous generation.
Yeah.
So another question is, how are the added IPC mechanisms implemented? So PubSub is basically a driver. You get a character driver, you open, you do ioctls to publish and subscribe, and then you read to get the actual notifications. In terms of guaranteeing real-time constraints for this is based on, it depends on the tasks that use this mechanism, since they have their own priorities. So some systems will, some tasks will get the same notification faster, and some will get them slower, depending on their priorities and when they are scheduled.
Okay. Andrei, did you use the high performance zero latency feature that bypass the Nuttx kernel, or you are using only the Nuttx kernel scheduler?
No, we're just using the Nuttx scheduler.
Okay, great.
There's another question from Lucas. How is the mechanism of communication between the UI and other threads? So mainly PubSub. UI itself is able to access drivers and such through the character drivers. But otherwise, with other tasks, it uses PubSub and our version of the key value store for basic values, basically. I mean, if you want to show heart rate, that's stored in the key value store and updated by the sensor task, and then the UI comes in, gets it, and displays it. Yeah. Are Fitbit applications abstracted from the hardware, and how is this done in Nuttx? So,
Andrei, before you
sure.
Respond, I want to explain. Nuttx is a POSIX RTOS, so we don't normally people don't need to worry about the hardware abstraction, because once you get the Nuttx running in some microcontroller, your application will work in all microcontrollers supported by Nuttx. That's correct? Please, Andrei.
Yes. So it's fairly easy to port, and our internal version of Nuttx has been ported to several chips just to test it out. Some of those were actually very quick to be able to run to a shell, for instance. Can I go on answering the questions?
Yes, we can. We have more time here. We can ask more some questions. Lucas again is asking about the low power implementation. Did you use
So
the Nuttx low power features or?
yes, so we basically use the Nuttx power management with a very low duty cycle. There is going to be a presentation by Vlad Rusicanu on the tickless modifications we've done to the scheduler.
Mhm.
And those improve our battery life quite a bit. So yeah, we use a Nuttx power management, but just very efficiently in terms of what the board itself is capable of. Since we do get to, as you've seen, 7 days or more.
Okay.
There's
We
another
have,
question. Oh,
yeah,
sorry.
we have another question. Andrei, instead I will interrupt you all the time. Please, you can go ahead and read it here. I think it will be easy. Okay.
So Slippery Seal has a very good question. Is Nuttx scaling well from your smallest devices up to your top of the line smartwatch? And any comments on what you find missing? So it's not running on any of our current smartwatches, but it has scaled well from the smaller trackers to the larger trackers. And those are, one is a superset of another, of course, but some of them have varying characteristics. So it was very easy to maintain a single branch for all of these separate devices and build at once and so on, because it is very modular. And some of the trackers especially have tighter memory constraints than others. So we've definitely leveraged the configurability of Nuttx to be able to optimize specific products to have lower memory usage. Another question is from Fani Kumar. Just curious on how is the support from accelerometer? Did you write your own algorithms for this accelerometer? So the support on the driver side, yes, we've written it. The algorithms for the pedometer, those are proprietary Fitbit algorithms that we've had and developed over the years. And yeah, it's a good selling point of Fitbit. How accurate is the optical heart rate sensor when using Nuttx? I don't know if Nuttx has here anything to do specifically. I mean, it does help that it's an RTOS, and we do get to run the algorithms quick, but the algorithms themselves are to credit for the accuracy of our heart rate readings. Oh yeah, somebody said the same thing I did. Are you using your own build system? For example, based on CMake as it is done in PixHawk? No, we do use the normal kconfig make. And that's it for questions right now. I think I've caught up to everything.
Okay. Lucas is asking if the conference will be recorded to be available later. Yes, it is streaming to YouTube, and we will break it in the video, and also your presentation. We'll share it later. The PDF that you sent us. Okay, if you agree, of course. We have another one. Andrei, if you want to read, or
Yeah, sure. Luis Linares says, did you face task starvation at some point? If so, how did you work around it? So there is Vlad's presentation, which definitely handles task starvation. We've also had some hardware constraints around task starvation that we've handled. We basically have hardware watchdogs, but also multiple software watchdogs at different levels. So there's a hardware watchdog that makes sure that there's a task with very low priority that has to run every 4.5 seconds, that otherwise reboots the tracker. There's software watchdogs that make sure that every task checks in every certain period of time. And if it doesn't, then it reboots the tracker. Rebooting the tracker, by the way, is very transparent to the user because we keep a lot of data in non-initialized memory, so the user is not affected almost at all by reboot. But we do want to maintain a good functioning tracker. But Luis, definitely look forward to Vlad's presentation, as it has some scheduler modifications that we did. Are you leveraging any kind of asymmetric multiprocessing for lower power usage or DSP cores? Yes, our current platform has a form of asymmetric multiprocessing. It's actually running 2 versions of Nuttx, 1 on each core. DSP cores not in our trackers.
Okay, I think we can finish for the question in the live chat. I will put here in the video description the link to the forum, so people can do more questions. Let's ask the last question from this Suzumu Ozeki.
Sumo Ozeki says, what are the benefits of using Nuttx for heart rate, such as real time? So yes, we basically have a high priority worker thread, which is already in Nuttx, that handles all the deferred work from the interrupts. So there's an interrupt from the HR chip, which is actually an analog to digital converter that's programmable. Once you get that interrupt, there's a HP worker that gets the data effectively, and then it's processed quite quickly by the sensor system. So I guess those are the benefits for real-time usage, because you don't get to miss out on that deferred work. And embedded systems asked a question that I can't answer because I was not around when it was changed to Nuttx. I inherited the system along with my colleagues, of course. Oh, but previously it was a bespoke system, not using an OS. Okay, I think that's it. So you can continue to ask questions in the forum for this presentation, and I'll be happy to answer those there. Also, as I said, look forward to presentations from my colleagues. Julian will talk about SmartFS and the additions that we've made to the Flash file system. Vlad will talk about some modifications to the scheduler, and Cosmin will talk about a lot of semaphores and priorities and so on. Alan, are you still here? There's a question I don't know how to answer. I'm not familiar with micro RAWs. There's a question I don't know how to answer. I'm not familiar with micro RAWs. There's a question I don't know how to answer. I'm not familiar with micro RAWs. And there's some echo. There's a question I don't know how to answer. I'm not familiar with micro RAWs. And there's some echo. So until Alan comes back, I can keep answering questions if you'd like to.
Alan just told me that he fall. Sorry for this. I am the second hoster, and I would like to know if anybody has some more questions. I don't think so. So I would like to ask you, thank you very much, Andrei, for this amazing presentation. And now we're going to have the next presentation at the next hour. And